So, dear friends, myself Satish Kumar Kamble, an assistant professor, Department of Physics, Abasai Marathi Arts and Newcomers Science College, Rajapur. So, today we will go through the paper second electricity and electronics from BSc first year semester second, unit, unit second electronics. The unit second electronics of this paper second electricity and electronics consists of mainly three chapters. The first chapter is nothing but the circuit theorems. Second chapter is DC power supply, and third chapter is digital electronics. All these three chapters belongs into the unit second electronics. So today we will study the chapter second DC power supply. So on the screen you can see the contents of this chapter: DC power supply from unit second electronics of paper second electricity and electronics. So under the heading of DC power supply we will study half wave rectifier, full wave rectifier, then bridge type rectifier, then peak inverse voltage and ripple factor of peak full wave rectifier. Then afterwards we will discuss about the clipper and clampers through the basic circuits. Then after getting the idea about the half wave and full wave rectifiers, we will discuss about the capacitor filter, and at last we will study the Zener diode as a voltage stabilizer. That is, the Zener diode can be constructed or used for the stabilization of the voltage. So let us start the chapter second, DC power supply. Let us have the introduction about this chapter. So what is DC power supply? So you can see the meaning of the DC power supply on the screen. A DC power supply is a type of power supply that gives DC voltage so that a device can be powered. Because DC power supply is commonly used on an engineer's or technician's bench for a ton of power tests, they are also often called a bench power supply. So, in this chapter, we shall study the applications of semiconductor diodes. Okay, under the heading of this DC power supply, we will study the major application of semiconductor diode. You know that the diode conducts current in when forward biased, and practically there is no current flows in a reverse bias. You have studied in the last year about the semiconductor diode. So the diode conducts current in forward bias, whereas practically there is no current flowing in the reverse bias condition. The unidirectional conducting property make it suitable to convert AC voltage into DC voltage, and it is known as the rectifier. Again, the semiconductor devices are very small in size. They are also cheaper. Then again, they are very lighter in weight. Again, they require the low voltage for their operation. Again, there is a high speed operation and operated they are operated with greater efficiency. So the semiconducting devices are high speed operation, having the high speed operation, and they get operated with very high efficiency. Therefore, integrated circuit, you know that integrated circuit, it is known as IC. Okay, ICs are possible with semiconductor applications. So you can see on the screen the next diagram here, figure or diagram, step down transformer. It is the constructed diagram of this step down transformer. We will use this device in the for our chapter for having the full wave rectifier and a half wave rectifier construction. Circuit diagrams. In circuit diagrams of half wave and full wave rectifier, you can see the symbol of this step down transformer. So step down transformer, we have to provide the input voltage from the socket, which is of alternating type or AC voltage. It is given to the primary winding or primary coil. NP indicates the number of primary coils in the step down transformer, whereas NS, it indicates the secondary number of secondary coils. Okay, through which we will take the output voltage. It will also be the alternating type or the AC voltage, but because this is a step down transformer, so our voltage here, input voltage is of 240 volt, 240 volt, so that here in the output terminals the voltage will be very low, say 12 volt, 9 volt, etc., depending upon the construction of this transformer. We can get the appropriate output voltage. Okay, both voltages have the same nature. Both are out of alternating type, that is the AC voltages. Only the amplitude or the intensity is here minimized in the case of the step down transformer. So this device is used in the construction of the half wave rectifier and full wave rectifier that we will see afterwards. So rectification or the rectifier circuits, rectification or the rectifier circuits. Rectification is the one of the process of converting alternating current or say the alternating voltage to direct current or direct voltage. The devices used for the rectification are called as the rectifiers. As usual, I have explained that the semiconducting diode or the semiconductor diode conducts the current easily when it is in the forward biased condition, and practically it does not conduct or practically conducts no current when it is in reverse biased condition. This unidirectional conducting property of the diode makes it suitable to be used as the rectifier device. Again, the forward resistance offered by the semiconducting diode in forward biased conditions is so small, and this forward resistance is different for direct current and alternating or varying currents. Again, the static or say DC forward resistance, static resistance or DC forward resistance of the diode is nothing but the ratio of instantaneous DC voltage to the instantaneous DC current. Okay, whereas the dynamic or say AC forward resistance can be defined as the ratio of change in AC voltage to the corresponding change in AC current. Okay, so now let us study what is half wave rectifier. So before to study the half wave rectifier, uh, let us see what are the types of the rectifier circuits. Most of the electronic devices require a DC power supply for their operations, but the electrical power which is available is usually by an AC supply. Again, in India, the AC mains signals changes sinusoidally with the frequency of 50 Hertz. You know that this we use it every day. We use the 240 or 240 volt AC supply, AC voltage, and it has the frequency of 50 Hertz. Okay, means the number of cycles completed in 1 second are nothing but the 50 cycles. Means the frequency of AC voltage that we are using in our everyday life is nothing but 50 hertz. Okay, so in India the AC mains signals changes sinusoidally with the frequency of 50 hertz, and therefore it has to be converted into DC voltage. The diode which convert AC current or AC voltage into DC current or DC voltage is called as rectifier. Now, there are two types of diode rectifier circuits for the purpose of the rectification used. There are two types of diode rectifier circuits which can be used for the rectification, and they are nothing but half wave rectifier, and second one is the full wave rectifier. Okay, so these are the two basic types of the rectifier circuits. Now let us study in detail the half wave rectifier. As usual on the screen you can see the circuit diagram of half wave rectifier. Here you can see here this is nothing but the AC supply. AC means 240 volt, that is 50 hertz frequency AC supply coming from the socket. Again, this is nothing but the step down transformer. Here, this coil indicates the NP, number of primary coils, number of turns of the primary coil, whereas this is nothing but a secondary coil. Just here we have seen here this coil, primary coil, this one is nothing but the secondary coil. In the same way, this one is the primary coil and this one is the secondary coil, and this is the symbol of step down transformer. Here the number of turns in the primary coil are very large as compared to the number of turns in the secondary coil. Okay, so this becomes the step down transformer. If we provide here the 240 AC volt, then we will get at these 2 points A and B very low voltage, but it will also be of AC type. Now this AC supply, which is of the very low voltage, is given to the diode. Okay, here the crystal diode is shown. Here this terminal is called as the anode, whereas this terminal is known as the cathode. And this circuit is completed by using the load resistance across which we are measuring or we are taking the output voltage. Okay, so in between points M L, we will measure the output voltage. So when we provide or we use the supply to this point, then here is the alternating voltage or AC voltage of this kind. Okay, this is V in, that is the input voltage supplied or given to this diode through these 2 points A, B. Okay, so this is of this kind. The voltage which we have provided through the step down transformer to the diode is of having such kind of the nature. So here is the alternate peaks are there. Here is the positive peak, here is the negative peak, here again it is the positive peak. So here is the alternating type voltage, that is the amplitude of this voltage, input voltage, changes with respect to time. Okay, at this point the amplitude is positively high, whereas at this point the amplitude is low but in a negative side. And this waveforms indicates the waveforms due to this output voltage. This is nothing but the output voltage which is measured across the points M, L. This is the input voltage given to the point A, B, in between A, B, okay, B in. So this was the constructed diagram of half wave rectifier. Here half wave, here is the one complete cycle up to this one. Okay, from this 0, again it is pi, again it is 2 pi, means one complete cycle. But in one complete cycle here we are getting only one half cycle. Okay, and here this term becomes 0 here. Here is no variation or there is no peak either at positive side or at negative side. So in one cycle of input voltage, at output we are getting only the one half cycle. So this is nothing but the half wave rectifier. Now the half wave rectifier is the rectifier which converts as usual AC voltage or AC current into DC current or DC voltage during the uh, positive half cycle. Here is the during the positive half cycle of applied AC, and it is therefore it is known as the half wave rectifier. Again, the circuit diagram of this half wave rectifier is shown here. In half wave rectifier, the AC supply is applied across the diode in series with load resistance RL. Now, during the positive half cycle, this one, during the positive half cycle of the input AC voltage, the point A becomes positive with respect to the point B. Okay. This makes the diode forward biased. That is, at point A or the point when becomes positive, then the anode will be provided by the positive supply, and therefore this diode becomes forward biased. So when the forward bias voltage across the diode becomes greater than the barrier potential. Barrier potential is 0.7 volt for silicon diode, and it is 0.3 volt for germanium diode. So when this forward bias voltage across these diodes becomes much greater than the barrier potential, then the diode works as close the switch, and therefore the large amount of current uh, IDC here IDC flows through the load resistance from point M to point L. Okay. This current produces DC voltage across this load resistance RL that we have shown here. Now, during the negative half cycle, this point A becomes negative, whereas this point B becomes positive. Okay. When this point A becomes negative, then the anode of the diode gave the negative supply or negative voltage. So the diode have the reverse bias condition. So during the negative half cycle of the input AC, the point B becomes positive with respect to this point A. This makes the diode reverse biased during the uh, reverse bias. During this reverse bias, diode works as the open switch, and therefore there is no current flows through this load resistance RL, and therefore there will be no voltage is developed. There is therefore no voltage is developed across this load resistance RL. So this is the zero voltage here for the negative half cycle. Now, therefore, the current flows through the diode during the positive half cycle. Uh, During the positive half cycles, because after having this negative cycle, there is again the positive half cycle, so that the process will be the same here again. So current flows through the diode during the positive half cycles, and no current flows during the negative half cycles of input AC voltage. So this figure shows the input and output waveforms of a half wave rectifier. Now let us discuss about the disadvantages of the half wave rectifier. There are generally two disadvantages. Uh, that the first one is nothing but this half wave rectifier converts AC to DC for only half cycles of input AC voltage. This is the one of the disadvantage of the half wave rectifier. Whereas we can say about the efficiency. The efficiency of the half wave rectifier is very less. We will find out it in the next article. So this is one of the second disadvantages of the half wave rectifier, that it has the very low efficiency. Now the concept of the peak inverse voltage. Let us talk about the peak inverse voltage. In short, PIV. Peak inverse voltage of half wave rectifier. It is defined as the maximum reverse voltage that can be applied across the diode without damaging it. Okay, without damaging it, the maximum reverse voltage that can be applied across the diode is nothing but the peak inverse voltage. The maximum value of reverse voltage across the diode during a negative half cycle of input voltage is V in. Okay, here. P in. Since the diode withstands at this value during the non-conducting period, the peak inverse voltage is P in. Okay. So in the next article, we will discuss about the efficiency of the half wave rectifier.